best way to really get a grasp of how coding works in CNC is to write a full program. So we are going to do that with a simple part that has got a few straight lines and a few radiuses and very simple measurements. But it will give you an idea of how these G codes and M codes work within a program. Now, this is the part that we have to produce with the CNC machine. The bottom left corner of the part is the datum. This is where we set the 0 position on this particular part. So, x is equal to 0, y is equal to 0 and z is equal to 0 will be on the top surface of the component. You can also put the datum on the bottom of the part, but due to that the sign convention will be reversed. So I would highly recommend you to keep the datum at the top of the component. That way, if we see any negative numbers in z axis, we will know the tool is cutting. Now the first thing the machine sees in the program is the program number. Now this is in brackets, which means the machine cannot actually read it. It's basically for us and it is called operator's note. Here we can write the date or year in which we are writing the code. At the end of this line we have a semicolon, which means end of block. This tells the machine that this line is at its end. So after every line of G code, we add an end of block code or semicolon. Moving on to the next line, we have another operator's note. Everything is in brackets, so this line is also not readable by the machine. This is purely for the operator to know what's going on. So the information we are delivering on this line is that T3 is the number of tool we are using, D is the diameter, and then a description of tool. And we end this line with the end of block, that is with a semicolon, to tell the machine this is the end of the line. Now, the first thing we tell the machine is G90, which means that we are using the absolute position system. So all dimensions come from our datum position. No matter where the cutter is or where we are going to take the cutter. Our next command is G94. This tells the machine that we are working in FPM or feet per minute. This is how we control the machine cutting tool when we are actually removing material. The next G code here is G91.1. Now this tells the machine how to work out where the center points of radiuses are. I, J and K are used to define the center points of radiuses, and they are similar as X, Y and Z. So we can say I is X, J is Y and K is Z. If you have some knowledge about vectors, you can simply correlate this. Next we have G40. This G code cancels any active cutter compensation. G40 just cancels any radiuses that the machine may have in its memory. Next we have G49. It is for tool length compensation. It cancels any offsets in the tool length. The next code is G17. G17 is our working plane, which means the XY plane. In other words, the flat plane of the machine table. Now if you are choosing dimensions to be in metric system, you have to write G21. And if you are working with imperial system, you have to write G20 here. For this particular exercise, we are going to use metric system and hence we will write G21. This line here is what is popularly known as safety line. You can just copy and paste it in your program, but it would be better if you learn them comprehensively. I have also provided the complete code in the description. So, with this, our preparatory function setup is complete. That means we are ready to write the program for actual operation. The first code that we are coming across in this program is M05. It tells the machine to stop the spindle just for safety reasons. That is, if by mistake spindle was running, this code will stop it so as to save the machine and workpiece altogether. Now, all the M codes and G codes that start with a 0 can also be written by omitting 0 as M5, and the machine will read it just fine. Next is M09, which is our coolant off M code. So, if the coolant is on, it will turn it off at this point. If it is not on, the machine will just skip this line and continue reading the rest of the program. Now here we have our first tool call. Now a tool call tells the machine which tool to load into the spindle and which offsets that we are going to use. So T3 tells the machine that we are using tool number 3, and this number is what we have designated inside the controls. And M06 is our tool change M code. In the next line of code, we have a S value. S value normally refers to the spindle speed or the rotation of the spindle per minute. We have selected a spindle speed of 12,000 RPM for the sake of this exercise. Now, the M code M03 tells the machine to turn spindle on in a clockwise direction. Now, if we want an anti-clockwise direction of rotation of spindle, we can use M04 as well. In the next line, G54 sets our working datum. G54 just tells the machine to read the information of our chosen datum so that all our dimensions and measurements come from the datum position on the bottom left hand corner of the part. Now here we have G41. G41 adds cutter compensation so that the cutter goes to the left of the component, whereas G42 would go to the right of the component as we are cutting. The D3 gives the diameter or radius of our tool. G43 is similar. G43 call upon the tool length offset so we can see how long the tool is. Z tells the length of the tool and H tells the tool height. M08 turns on our coolant. Now we get to our first line where we start moving the cutter. The G00 is the rapid traverse command which moves the cutter in fastest possible way to our position of x is equal to 0 and y is equal to -20. Now you might be wondering why there is a minus sign for y-axis. This is because we wish to start away from the component as we bring the cutter in. So rather than coming down right on x is equal to 0, y is equal to 0, that is our datum, we have come off the y-axis by 20 mm. This will give us a greater dimensional accuracy and better surface finish as we start machining the part. Now as we move to cut around, our rapid travel command G00 is still at its tool change height. we are going to wrap it down to 5 mm above the job. Now using G01 with a jet depth of -5 mm, we will take the cutter 5 mm deep into the material. Let's assume it's a 5 mm thick material, so this would take us right the way through the material. We also need to issue a feed rate to tell the machine how fast we are going to come into the material. So a feed rate of 250 mm per minute would be suitable. Now with our cutter through the material, we can speed up the feed rate a little bit as we feed in X or Y axis. So we are going to add a feed rate of 300 mm per minute, which is 50 mm per minute more than the previous one. So this 300 mm per minute feed is what we are going to use while we are cutting this profile. Now G01 is still active from the line above, so we don't need to state that again. Now for the next move, we are taking our cutter up the y-axis by 160 mm, up from the datum, and because it's up from the datum, it's a plus figure. Now, why we are taking 160 and not 180? Because this takes us to the beginning of the radius. We have a 20 mm radius here, and we wish the cutter to be at the beginning point of that radius, so we are moving at 160 mm at the datum position. We are now ready to cut our first radius, and for that we use G02. This is our clockwise radial move, so the machine knows which way the radius is going. We simply have to state a center point of the radius and an end point to be able to cut this. So, where our tool was at the start of the radius, we take the center point of the radius as an incremental move. So the incremental move along the x-axis would be in I, because I, J and K represents X, Y and Z in G code. So this would be a plus direction because it is to the right of the cutter and the dimension is taken from the cutter and not the datum. Now remember, absolute is the position from the datum, whereas incremental is a position from the tool. So the X and Y positions here is the end point of the radius from the datum. Because we are working in absolute through our usual control methods of this particular machine. But when it comes to defining the center point of the radius, that's an incremental one. So I would be 20 mm, that's 20 mm away from the start point of the tool along the x-axis, and Y would be in line with the tool, so this would be 0, and hence J would also be 0 as that represents Y. So this line of code would move our cutter around a 20 mm radius where the center point is 20 mm away from the x-axis and 0 along the y-axis. And we define our finishing point by using the x and y coordinates. Now, our next movement command is a simple straight line. So for that, we are going to use G01. We need to declare G01 here as the previous line had G02 already defined. During the first cut, we told the machine we were cutting the radial. Now, we need to tell the machine we are cutting linear again. So, we just need to give it an endpoint in the x-axis, and we don't need to tell it the y position because it assumes it's not moving in y if we don't give it a dimension. Now the next code line are quite similar to what we have been doing so far. You can simply understand these 5 to 6 lines by keenly following what you have learned. This goes till point D on the diagram. Now, all that's left to do is to move the cutter back to the start position and a safe place where we can lift it. from the material. So G01x-20 will bring the cutter 20 mm to the left of our datum position, and that brings the cutter over to where it's shown on this drawing. So now we can lift the cutter away from the component. Since we have finished cutting, we can lift the cutter right out of the material as fast as we like. So for that, we are again going to use the rapid traverse command G00. Now we need to bring the tool 15 mm above the surface of the material because we had set our datum on the surface of the material. So any minus number would be cutting and any plus number would be above the material. Now G00 code is still active and we can now move our cutter back to its home position. Remember, this is the machine's home position we are talking about. So it would be x is equal to 240 and y is equal to 240. We can also add M09 to turn off the coolant. When we are writing M code in the program, we can only write one M code per line. So to turn off the cutter, we will write M05 in the next line. Earlier, we have also used cutter compensation on this component where we defined G41. We can turn it off by writing G40 code. And finally, we have the M code M30 to finish the program. This coding exercise for CNC machine is quite simple but lengthy one. But it covers all the basic information you need to learn to start learning CNC programming. I would highly recommend you to watch this lecture over and over again so that you can get familiar with different codes and you can eventually start writing your own in no time.